I was born in the midst of one of the largest bark beetle outbreaks in North America. A recent resurgence has brought the total area of forest in Alaska affected up to 4.7 million acres, an area about the size of New Jersey. In the hardest hit stands, 90% of mature spruce were killed, turning beautiful old forests into giant games of pickup sticks. With Alaska's rapid warming, climate thresholds allowing for further outbreak have been surpassed, indicating a dire threat to the boreal forest, one of Earth's most important carbon sinks. Even now, the pristine wilderness of Denali National Park is being encroached by this human-accelerated disturbance, a disturbance which could increase fire risk, hazards, and carbon emissions. Another threat to Alaska's beleaguered forests is wildfire. Due to wildfires' increasing size and frequency, more resources than ever are being invested in fuel reduction treatments, also known as fire breaks or fuel breaks. Fuel breaks are an effective and necessary tool for protecting communities. But what if they also make bark beetle outbreak more likely? Now, I'm not saying stop building fuel breaks, just that someone should identify the fuel break characteristics that drive bark beetle population growth. That someone is going to be me. Now, why would I expect fuel breaks to impact bark beetles? Well, bark beetles live in the delicious inner bark of trees, which have defenses to kill them, primarily by encasing them in resin. Thus, beetles prefer stressed trees with weakened defenses, or even better, freshly dead trees, stumps, and branches, known as coarse woody debris. Similar disturbances, like logging and windstorm, have been linked to increases in bark beetles. But with fuel breaks, we just don't know yet. The study I am proposing will take me to fuel breaks across Alaska. There, I will measure factors that may impact bark beetles, such as construction method, tree health, and treatment of slash. I will also measure bark beetles themselves by luring them into traps using their own pheromones. I hypothesize that the fuel breaks that create lots of stressed trees and coarse woody debris will have greater increases in their bark beetle population than those that do not. This research will benefit land managers, the fire science community, and people living in the boreal forest. Following the study, I will deliver an outbreak risk assessment of each site I visit to the relevant land manager, so managers can make strategic decisions that maximize field break effectiveness while minimizing the risk of outbreak. This study is my first step towards protecting the forest I call home.